Right, so in this video what we're going to be looking at doing is using our exponent laws to simplify different expressions that if we were to try and type them into our calculator, generally it'll work if you've got a scientific calculator, but then you've got to be really careful with how you're typing it in. It becomes kind of a pain in the butt to make sure that you're putting it in exactly as it is. And then some of the numbers just get too big, so even if you try to do it in separate parts, the numbers are just going to be too large and it's not going to work. So I'm going to use the exponent laws to simplify some very difficult expressions and make evaluating them actually quite simple. So with this one, I've got 2 squared times 5 exponent 5 divided by 5 cubed inside a set of brackets, and then outside the set of brackets I have an exponent of 3. So generally, as a rule of thumb, what I like to do is I like to try to simplify inside my set of brackets first if I can. So here I have 5 with an exponent of 5 divided by 5 with an exponent of 3. So I can use my quotient law, which tells me that since I'm dividing and the bases are the same, I can keep the base the same and subtract my 2 exponents. Okay? So I'm going to instead write it as 2 squared times 5 with an exponent of 5 minus 3. And that's all in brackets, and the exponent of 3 is still outside. Okay? So that simplifies now to 2 squared times 5 squared, and that's then raised to an exponent of 3. Now there's a couple different ways I can do it from here. As long as you're following an exponent law, it doesn't matter what order you do these things in. If you're following an exponent law, you can't do it wrong. Okay, so what I'm going to do is I'm going to bring that exponent of 3 inside my set of brackets using the product law. So the product law tells me that if I have a product inside the set of brackets, then I can bring that exponent into both factors in my product. Okay, but inside my factors already have an exponent. So I'm really doing this now where I've got 2 squared is going to be cubed, so I have to use the power of a power law, which tells me to multiply those 2 exponents together. So I'm going to write that as 2 with an exponent of 2 times 3, and then that's multiplied by 5 with an exponent of 2 times 3. Okay, and that gives me 2 exponent 6 times 5 exponent 6. Now I actually can simplify this even further because both of these things have the same exponent. Okay, now this is something that we use the product law for again, but I'm going to work through it backwards. So if 2 things have the same exponent, I can write the product inside a set of brackets and move that exponent outside. So that's going to give me 2 times 5 with an exponent of 6, and that's the same thing as 10 with an exponent of 6, and that I can evaluate without a calculator because I know I'm going to have a 1 followed by 6 zeros. So the answer is 1,000,000. Okay, no calculator required. All I used was the different exponent laws. Okay, now I could have, at this point, back up here, I could have said, oh, well, I'd like to write that as 2 times 5 squared and then cubed. And 2 times 5 was 10 squared, and 10 squared cubed is 10 exponent 6, and we still get the same thing. It doesn't matter what order we go in, as long as we use exponent laws and we use them correctly, we still get the same answer. Okay, let's look at another one. So in this one, in brackets, I've got 4 squared times 5, and that is cubed, that whole product, times by 5 again, and then divided by 2 exponent 12. Okay, so again, I would normally start with simplifying in my brackets, but there's nothing really in there to simplify. So I'm just going to use my product law again and bring that exponent of 3 inside to both things in my product. Okay, because the 4 already has an exponent of 2, I have to multiply those 2 exponents, so 2 times 3 gives me an exponent of 6, and then I have times 5 with an exponent of 3, times another exponent of 5 in the numerator, and then divided by 2 with an exponent of 12. Okay, the 5s aren't so bad. I can see really easily that I can combine those 2, that 5 exponent 3 times another 5. Remember that if we have a 5 with no exponent, or any number with no exponent, the exponent we assume is 1. So I have 5 with an exponent of 3 plus 1, so that's going to give me an exponent of 4. And so I have 4 exponent 6 times 5 exponent 4 over 2 exponent 12. Now at this point, I still have not done anything to make it so that I can solve this without a calculator. Okay, so I can hopefully remember that another way of writing 4 is 2 squared. So instead of writing 4, I'm going to put it in brackets. I'm going to put my 4 in brackets, and I'm going to think of 4 as being 2 squared instead. It's just another way of writing the same number. 4 is composite, so I'm going to write it as its 2 factors. And when I do that, 2 exponent 2, then raised to another exponent of 6, those exponents 2 and 6 are going to multiply together. So now I have 2 exponent 12 times 5 exponent 4 divided by 2 exponent 12. And I have the same thing in the numerator and denominator. I have that 2 exponent 12, and I'm dividing by 2 exponent 12, so I subtract those exponents. And I've got 2 exponent 12 minus 12 times 5 exponent 4. Well, that's going to give me 2 with an exponent of 0 times 5 with an exponent of 4. 2 with an exponent of 0 is just 1. So I've got 1 times 5 exponent 4. So I really just have 5 with an exponent of 4. And if I wanted to evaluate that one, it's 625. Okay, nice and simple. So that wasn't so bad. Now, did I need to write all that out to get exponent of 0? No. If you see you have the exact same thing in the numerator and denominator, and all we're doing is multiplying and dividing, they can cancel one another out and just be replaced with ones. Okay, just like putting a fraction into lowest terms. If you see a common factor, numerator, denominator, remove that common factor. Okay, all right, now I'm going to do a really hard one. This one I put on one of my tests, and if anyone got it right, they just automatically got a 4. So I'm going to show you how we would do something really complicated like this. There's no way in the world I want to try typing this into my calculator. Okay, so I'm going to go step by step. Let's look at this first set of brackets. Okay, so in this first set of brackets, no real simplifying I can do here, nothing that looks that easy. So I'm just going to bring that 10 in using my quotient law because I have an exponent on my fraction. Now because both the numerator and denominator already have exponents, I'm going to multiply the exponents together. So that's going to give me 4 exponent 20 over 10 exponent 50. And then I've got times 15 exponent 40 over 21 exponent 35. Okay, now I have this division sign, and I'm going to change this right away because I'm dividing a fraction, and I don't want to divide a fraction. I would much rather multiply by the reciprocal. So I'm going to flip the numerator and denominator. They're going to trade spots. So I've now got my 35 exponent 11 times 49 exponent 12 times the 6 exponent 12 divided by 9 exponent 8. Now, I haven't done a lot in terms of making things look simpler, so let's start maybe trying to find some easier things to work with. So one thing you might notice is that all of these numbers are composite numbers. That means they're made up of factors. So I'm going to split all of my numbers, my composite numbers, into their factors. Okay. Now, the other thing that I've got going on is all I'm doing is multiplying. Okay, so since I'm multiplying, it would be the first numerator times the second numerator times the third numerator, and my first denominator times my second denominator times my third denominator. So really, I'm just going to write it as one super fraction. Okay, now yes, that doesn't help with my cross-reducing, but using exponent laws, cross-reducing might not be very necessary. So let's look at this here. All right, first thing, 4 exponent 20. So instead of writing 4, 4 is the same thing as 2 squared. So I'm going to write it as 2 squared with an exponent of 20. Okay. The second thing in my numerator, 15. 15 is the same thing as 3 times 5. So instead of doing 15 exponent 40, I'm going to go 3 times 5 exponent 40. For 35, that's 5 times 7. And I've got exponent 11. For 49, 49 is 7 squared. So I got 7 squared to an exponent of 12. And then 6 is 2 times 3. Okay. Lucky me. I've made my numerator even longer than it was before. Okay. But at least I'm breaking it down into smaller powers. Okay. So 10, we're going to rewrite that as 2 times 5. Same exponent outside. The 50 stays there. 21, let's write that as 3 times 7. Exponent of, oh, sorry. Here I am writing 21 because I said it out loud. Exponent 35. And then the 9 is the same thing as 3 squared. So that's 3 squared with an exponent of 8. All right. We got something crazy going on here now. I'm going to bring in all my exponents into my sets of brackets. Okay. So for the first one, I've got 2 squared to an exponent of 20, so that's now 2 with an exponent of 40. Then I've got my 3 with an exponent of 40, and a 5 with an exponent of 40. And I'm just using different colors, and you'll see why in a second. I'm just going to keep different colors for all of my different bases, because that's going to make it a little bit easier for us to see as we go on. Then I've got 5 with an exponent of 11 when I bring that one in, and 7 with an exponent of 11, everybody's favorite combination. Okay, and then we've got 2, or sorry, and then our next one is 7 squared to an exponent of 12, so when I multiply those exponents, we get 7 with an exponent of 24. And then we're on to the 2 times 3. So the 2 gets an exponent of 12, and the 3 gets an exponent of 12. Okay, all right. So my numerator now is written out and all in simple powers with nice simple bases that can't be broken down any further. Denominator now, so we get 2 with an exponent of 50 times 5 with an exponent of 50. 5 was green. Okay. And then we've got 3, and that's red, so we've got 3 with an exponent of 35, and then we've got 7, exponent 35. I wish I had a simpler way of switching colors. And the last one we have is 3 with an exponent of 16, because 2 times 8 is 16. Okay, now I wrote them all out in different colors. I did that on purpose because since all I'm doing is multiplying, multiplication is commutative. So I'm going to write all the things that are the same colors next to one another. Okay, means I can switch my multiplication around. I can do it in whatever order I like. So I'm going to put my 2's all at the front. So I got 2 exponent 40 times 2 exponent 12 over 2 exponent 50. Okay, and then I've got my next one is my 3's, so I've got 3 exponent 40 times 3 exponent 12, and in the denominator, I've got 3 exponent 35. I'm just writing them near one another, even in the numerator denominator, or sorry, even in the denominator. And the fourth one I have is 3 with an exponent of 16. Okay, on to my green, so that's my 5, so I got 5 exponent 40 times 5 exponent 11, and in the denominator 5 exponent 50. And finally the blue for 7, so we got 7 exponent 11 times 7 exponent 24 over 7 exponent 35. Okay, all right, now that everything that's the same color is written near one another, okay, it's still one giant fraction. So I'm going to look at this first part here with the 2's. In the numerator, I would add those 2 exponents. Okay, so it'd become 2 with an exponent of 52 over 2 with an exponent of 50. Hopefully you can kind of see where I'm going now. Then I've got in the numerator for my 3's 3 exponent 52, and in the denominator 3 exponent 51 by adding those separate exponents. For the 5's, we've got 5 exponent 51 over 5 with an exponent of 50, and for the 7's, we have 7 exponent 35 over 7 exponent 35. And at this point, I'm very excited because our 7's, we have the same exponent, top and bottom. Those guys cancel. I no longer have any 7's to work with. That's very nice. Okay. All right, using my quotient law, oh, I don't want that. Using my quotient law, I can subtract those exponents for 2. So I'm going to take the 52 minus the 50. Using the quotient law for the 3's, I'm going to subtract the 52 and the 51 for the exponents of 3. And the same thing for the 5's, I'm going to subtract the exponent of 51 minus 50. And that now leaves me with 2 squared, and 3, and 5. And this has now become very simple. This is now 4 times 3 times 5, and that's 12 times 5, and that's 60. So if I go all the way back up to this expression we had at the very start, the answer is 60. Okay? Now, very difficult. Too much to type into my calculator. A real pain in the butt. If you got a good scientific calculator where you can see your whole expression, yep, you can probably type it in. But you'll probably spend just as much time typing it in and making sure it looks perfect as I spent doing my exponent laws and doing it without a calculator. Remember, your brain is the most powerful calculator. Use the different tools you have to simplify some of these things. All right, have a good week, guys.